Sinkhole can form, one thing, if you have a lot of rain forming, the land underneath can sink and give way and cause some damage. You can also extract water or groundwater. If you extract a lot of groundwater, you have a lot of these open spaces, open pores in the rock, and that rock can give way and collapse. Also, old mines can collapse. Old mine collapse. A lot of times in Florida, you have underground caves that can collapse.
I think there was a movie where one of the caves collapsed. It was like October or something.
Yes.
Is that the name of the movie?
I don't know.
It was like...
Okay, what else?
October Sky, that's what it was.
Yes.
You say compare weather by water, ice, or wind and gravity.
Weather by water, wind, ice, and gravity. Yeah.
What about gravity?
Gravity for erosion by gravity. Whoops. Yep. Those are landslides, rock slides, avalanches, or rock falls. It's number 10. Okay. What else?
Oh, this is.
Yes.
He's over there.
Number 11. Number
I
11.
have someone else in my seat.
Explain the best location for development to reduce impacts by geohazards and protect property. Okay. Well, where shouldn't we be building? One thing.
Underwater.
Seriously. Below. Okay, so we should not be building below sea level.
On a fault. That's a bad idea.
Fault lines. Near volcanoes.
Right next to the
Wetlands due to flooding. I'm going to add flood zones. Like river valleys. They're flat.
cracks.
They're flat for a reason. Okay, so when it floods, the river can just pour over the flat land and go back in. If you build a house there, you need flood insurance, and that's not cheap. Okay. Okay. Now, what about along the coastline? Yeah. Well, you really. I mean, the barrier islands we have in North Carolina, they're a barrier island for a reason, right? They protect the mainland across the inlet. Should we really be building on there?
No.
No, we really should not.
Atlantic Beach.
Okay? Because one thing, they are so small, they're going to be hit by hurricanes. They're going to cause property damage. Should you build, if you're going to build, should you build a house on a slab foundation?
No.
No, you should not. Build it up on, up off the ground, so if it does flood, if there is storm surge will just go underneath your house. Hopefully, and your house will survive. Now, it doesn't always happen, obviously, but you hope that can happen. Bottom of mountains, not a good idea due to risk of avalanches, landslides, rock slides. Along the coast, you got to protect yourselves from tsunamis. Okay, what else?
Earthquakes.
Yep, along fault lines right here.
That's it.
Okay. Other things you want to go over? North. How do lithospheric plates move? First, actually, let me pull up an image. Let's go to. I'm going to talk about seafloor spreading. There we go. So here we have a picture of magma that moves upward. Once it moves upward, it'll cool and create new oceanic crust. As that oceanic crust is formed, the new oceanic crust is spread apart that way and that way. Yes?
When the magma and the ocean water make direct contact and form that solid immediately,
Yep.
will that steam at the bottom of the ocean or whatever that chemical reaction is eventually hit the surface and we can see it or no?
No, it's so far deep. It's so deep in the ocean that whatever chemical reactions taking place will stay down there. Now, originally we thought that at vents like this, where there's volcanic gas being escaped from the mantle, we thought there's no way life could survive, because one thing, the water's boiling and it's highly acidic. However, we went down there, we saw life. Fish, plants, worms. They could survive water that is boiling. It's just amazing.
I guess
Okay.
you can't eat them.
Probably not. Now, how the stuff moves over time, the crust moves as you keep adding more and more magma, more and more new oceanic crust. So that in this area here, what kind of zone is that? That's your subduction zone.
Does that mean when the continental crust or the oceanic crust goes under the continental crust?
Yep, exactly. When the oceanic crust subducts or goes underneath the continental crust. This is where we're going to get our volcanoes to form. Also, in this area, we see the deepest parts of the ocean in the trenches. Okay, the ocean trenches.
Like in Japan.
Like in Japan.
That's where the earthquake occurred.
Exactly, yes. Deepest part of the ocean is the Marianas Trench in the western Pacific. We do not have a trench off the North Carolina coast. We have the continental slope and shelf, and it flattens out to the abyssal plain. And this area here would be the abyssal plain before the mid-ocean ridge.
Isn't it just flat?
It's very, very flat,
Do
yes.
fish live in the abyssal plain?
Yes, they do. So if we do this, abyssal plain, there we go. So pretend that this is North Carolina coast. We got the Appalachian Mountains over here. Hey, I'm from the north. What do you want? We have the coastal plain from, like, say, Raleigh eastward in this area here. Then we have the shoreline. You have the continental shelf just offshore. When you go out into the ocean, you're walking along the continental shelf. It can drop pretty quickly.
Like in Hawaii.
Like in Hawaii.
Right in front of you.
And then you have the continental slope, kind of slope down here. And then continental rise, that's kind of a shallower slope. And then it flattens out into the abyssal plain. Okay. Now there are these underwater canyons like they have here. Those were formed many, many thousands of years ago because at this point, at this area of North America was actually, it was risen up a little bit, and we have like the Neuse River, Cape Fear River, actually extended further outward into the ocean and cut down these canyons. Now these canyons are just underwater. These old river valleys are now underwater. Well, unless you get some dense ocean water that's flowing down now, it's the erosional process will slow down. Because you also have all these sediments coming from the mountains and being deposited onto the continental shelf and slope.
Will it eventually be that the mountains will flatten out and the ocean will rise?
Well, more or less, yeah. I mean, the Appalachian Mountains are continually getting smaller and smaller.
Aren't they the oldest mountains in North America?
Yes.
Because the Rocky Mountains are younger because they're not as eroded.
Exactly. The Rocky Mountains are much higher, but they're much younger. Appalachian Mountains are smaller, but they're a lot older.
Okay. So wait, what's the flat part before the drop? The continental shelf.
Continental shelf.
Coastal plain, continental shelf, kind of slope.
Slope, rise.
What's the rise?
It's this area here, so if we put another cross section, here's the abyssal plain, continental rise, slope, and then the shelf, and then the shoreline. Okay, so kind of like, and you have the water right there. So this here is the rise.
Why do they distinguish the difference?
Because it's a different geological feature. Okay, it's just and this is the plain, the abyssal plain. So here, if you're walking along here, start going uphill, slight uphill, then a really steep slope, like that. Think of it as like an exponential curve. Okay. Exaggerated, but. Yeah. What else? Tony. Yep. You should be able, guys, at this point, be able to look at a map like this. If I zoom in, you should be able to look at a map like this and pick out where the plate boundaries are.
No, okay, that's easy.
Okay? Pretty much 99% of the time, wherever you see the volcanoes, that's where you have plate boundaries. Okay? So, obviously, we've got tons of volcanoes here in the Pacific. The Ring of Fire, over here, all the way here, there. Okay? Tons of volcanoes. Volcanoes here. What's this?
Oh, the Mid-Atlantic Ridge.
Mid-Atlantic Ridge. Most of these are underwater volcanoes, save for Iceland, where most of them are above water. You have a new divergent plate boundary forming right here
That's like
in East Africa. You have convergent boundaries in Italy and in the Caribbean. Okay? And over here in the southern Atlantic.
there are a lot of volcanoes in California.
There's a few, mostly in Northern California. Okay? A lot of them in this part of the world too. The only really big exception is Hawaii. Is that a plate boundary?
No, it's a soft spot.
It's a hot spot.
Hot spot.
Not a soft spot. Hot spot. Hot spot volcanism. Weak spot in the crust that allows magma to move upward. To form volcanoes. Hot spot doesn't move. The crust moves over the hot spot. Okay? That's why we have the big island of Hawaii and Oahu. No, big island in Maui, then Oahu, then Kauai, Molokai, etc., all the way to Midway Island, Guam, all those. Okay?
Moving up.
It's moving, well, the whole crust is moving that way. More or less. What else? Tony. Yeah, more or less, pretty much. It is spreading. These ones are kind of... Now, different parts of the crust are moving in different directions. Like, this part of the North American plate is moving to the northwest, and this part's moving that way. So they're moving side by side. They will not be ever moving in the same direction. Something else?
Yeah, convection cells.
Okay, convection cells. Let me pull up an image for that. This is going to explain how how magma moves throughout the mantle. So here, wherever we have a subduction zone here, magma below it in the mantle is also moving in that same direction. So it'll move this way and then go down. Go down deep into the mantle, then back up where you have the mid-ocean ridge. So that this part's spreading that way, that part's spreading that way. So as the magma moves upward, it'll also move that way. This is it's almost the same thing, same concept when you're boiling water. It's a convection current. That's why when you're cooking spaghetti, the spaghetti is moving around real fast, right? It's a convection current inside the boiling water.
So it's not because of the bubbles?
What?
It's not because of the bubbles?
The bubbles are just the gas in the water that's escaping. It's water vapor. But it's just moving water. That's all it is. Because the bottom of the pot is very, very hot, 100 degrees Celsius. The top of it is just slightly cooler. So the hot water moves up, the cold water moves down. It's just a whole current, just like the Lee convection lab we did. Okay. So I'll put this video on YouTube, and